let me, why is it not working? Go there. Is it? Oh my god, please. Okay, cool. Still getting used to this. All right. So, this is similarity practice. This one I'm gonna take my time on explaining why, like the why, what, why, and how I'm doing things. But this should hopefully lay the foundations to how to set up the what are they called? Proportionality equations and why they work. So let's see. We got triangle, triangle of height 12. I'm just gonna. It doesn't actually matter what kind of triangle you draw, and I'll get to that in a second. Height of 12, area 36. Then you have a similar triangle, which means all the angles are the same. Let's say it's a right triangle, but it really doesn't matter as long as all the angles are the same. And this, oh wait, no, the first area is 24. And area here equals 36. Now, first what I'm going to do is solve for h to the 2/3 manually, how you normally would. The height is 12 and the area is 24. Area equals 1/2 BH, H, so 24 equals 1/2 times 12 times B. You solve for B, and you get 3 equals B. That's right, that's not right. 4 equals B. I suck at arithmetic. 4 does not equal 3, it equals B. Oh my god, don't mind me. 4 equals B. And then, from there, you know that area equals 1/2 4 times 12. And okay, actually that's not true. Well, I mean it is true, but area equals 1/2 base times height. If you wanted to make a proportion here, you can go. Sorry if I'm talking quieter. My parents are asleep. But area 1 to area 2 is equal to 1/2 B1 H1 over 1/2 B2 H2. Now the obvious part is that the 1/2s cancel out, but now we got to look at the H's and the B's. We know from this that H is 4 is B, or B is 4, and H was, what was it, 12? H equals 12. That means that, actually, do we even need that? Well, okay, I'll tell you right now, we don't need that, but I mean, talking about explaining how this works, I'm wondering if we need that. So, I don't know if that's the best way to explain this. My bad. I'm just thinking about this. I didn't really go into this with any lesson plan. Okay, I'm gonna try to explain this a different way, because I don't know why I'm blanking on this method. Why am I... What about, yeah, I really don't know why I'm blanking on this method. Let's look at a triangle. That's gonna look awkward, by the way. Let's look at a triangle. And then let's look at a smaller triangle inside of it. This has a height of H1 and a base of B1. This is height of H2. Sorry, this entire thing is H2. Let me get rid of that. And this has a length of B2. if you look at the triangle, and H1 and B1 don't necessarily have to be the same, but if you look at the triangle, as you increase your height, you're going to be getting a larger base as well. As you increase your height, as you go up, your base is going to increase, which means that, oh yeah, this is a nice way to do it. Height is proportional to base, because as height increases, base is going to increase linearly. Yeah, that's fine. Okay. Now, if you know how to translate proportionality into a equation, then you'd know that the way you do it is just to add some proportionality constant, c, for example. Height is equal to base times some constant c, and that makes up for whether or not h expands faster or slower or whatever. If say you've got something like that, where height, as you increase height, height is going to increase much faster than base. As you can see here, that proportionality constant accounts for that fact. So why is this useful? Well, you know that h equals bc, which means that over here, when you set up this equation to use that fact, I'm actually gonna, you can switch sides, you can just say there's another constant on this side. It doesn't really matter. It won't be the same constant, but there will be a constant on one of the sides. The only reason I'm doing that is because I want everything in terms of height. So B1 becomes H1 times C. H1 times C. That's B1. Then this comes down, H1 again. Over, and this constant does not change because it's a proportionality constant. Same thing happens down here. H2 times C, because that's B2, times H2 from that. That arrow does not point anywhere, but anyway, the point is that you end up with H1 squared over H2 squared times C over C. These cancel, and you get your proportions. A1 over A2 equals H1 over H2 squared, those two squared. This extends to 3 dimensions, if you really want it to. That is, okay, oh my god. Yeah, that works. If you were to increase in height here, you'd see that there's also some kind of change in this length, that length, in all 3 directions. And you're going to have the same effect as you had here with more constants, but they'd all cancel out. So that is the point of proportionality. Now I hope that makes sense, and it'll make the fact when you know this, and you can observe this and immediately if you know what you're looking for, it makes the rest of this really easy.